Memory is one of the most important parts of being alive. We use it every day, constantly, without even thinking about it. We use it to remember what happened yesterday, what worked last time, what failed before, what someone told us, what we promised, and what we are supposed to do next. But memory is also stranger than that. Sometimes you meet someone for just a moment, barely thinking about them. Then days later they show up in a dream. Sometimes a smell or a sound brings back an entire moment from years ago. Sometimes you are stuck on a problem, and suddenly some unrelated experience becomes useful. That is what makes memory interesting. Memory is not just storage. It is not just a database. It is not just a folder of notes. Memory is dynamic. It is associative. It is reinforced by repetition, but also by novelty, surprise, confusion, and usefulness. Some things are remembered because they happen over and over. Some things are remembered because they happened once, but changed how we understood everything around them. And if we are building coding agents that are supposed to work with us across real projects, I think they need something closer to that. Not human memory exactly, but something more alive than static notes. That is the idea behind RadialRecall. RadialRecall is my attempt to build a repo-local memory layer for OpenCode. It records what happens in a project, stores that activity as a graph, recalls useful memories when new work resembles past situations, and learns over time which memories are actually useful. The goal is not to give the model more context. The goal is the right memory waking up at the right time. Why coding agents need memory. Modern coding agents already have tools. They can read files, they can edit code, they can run commands, they can search a repo, they can inspect errors, they can make plans. But most of them still struggle with project continuity. They can be useful inside one task, but across sessions they often forget the lived experience of the project. They forget which package manager this repo uses. They forget which test command worked last time. They forget which files were involved in a recurring issue. They forget what a fix already failed. They forget that a certain bug has appeared before. They forget small project specific patterns that a human developer would slowly build up over time. And real software projects are not just a collection of files, they are histories. A repo contains decisions, mistakes, patterns, conventions, hidden constraints, failed attempts, and fixes that only make sense if you remember what happened before. So the question is, can we give a coding agent a memory system that grows from the work it actually does? That is what RadialRecall is exploring. Existing approaches. There are already ways to give agents memory. The simplest is static project context. In OpenCode, something like agents.md is useful. You can write stable instructions like use PNP, run this command for tests, follow this architecture, do not edit generated files. That is valuable. But it is static. It is more like a rule sheet than a living memory system. It does not naturally learn from what happened. It does not know that a bug came back, that a retrieved memory helped, or that an old note became noise. The other common approach is RAG, RAG, Retrieval Augmented Generation. RAG is extremely useful. It lets a model search external information and bring relevant chunks into context. For many use cases, that is exactly what you want. But for coding agents, RAG often feels more like a library lookup system than a real memory system. It usually asks, what stored text is similar to this prompt? But project memory needs to ask something deeper. Have we been in this kind of project situation before? What files were involved? What command failed? What fix worked? Did this memory help last time? Should this memory wake up again, or should it stay quiet? That is the limitation I keep running into. RAG retrieves information, but memory should activate useful experiences. And coding work is not just text. Coding work has structure. A task usually looks something like this. You have a prompt, the prompt creates a file, the file has edits, the edits take commands, the commands give you errors. The errors and solving those errors are outcomes. RadialRecall is built around that structure. What RadialRecall does differently. The core idea is simple. A useful coding memory should be connected to the work that produced it. A memory should not just be an isolated node. If the agent learned something while debugging a bug, that memory should remain connected to the prompt, the files, the edits, the commands, the errors, and the outcome that created it. So RadialRecall represents project activity as a graph. Prompts become nodes, files become nodes, edits become nodes, commands become nodes, errors become nodes, memories become nodes. And the relationship between those things become edges. So instead of only storing, for example, water seams were fixed by changing neighbor lookup, RadialRecall can store the surrounding situation. The user asked about water seams. The agent inspected the file chunk.cs. The agent then inspected world.cs. The issue involved chunk boundaries. The relevant edit changed neighbor lookup. A memory was created from that region. Now later, if the user says transparent blocks are splitting at chunk borders, the wording is different, but the project situation may be structurally similar. It may involve the same files, the same subsystem, the same boundary pattern, and the same prior memory. That is the difference. RadialRecall is not only trying to match text, it is trying to recognize the shape of a project situation. Nodes and edges. The graph has two basic pieces, nodes and edges. A node is something that the system observed. The main node types are trace nodes, file nodes, edit nodes, command nodes, error nodes, and memory nodes. A trace node is usually a user prompt or task moment. A file node is a file involved in the work. An edit node represents a write, edit, or patch. The command node represents something the agent ran. An error node represents a failure, expectation, or command error. And a memory node is the compressed lesson. Edges connect those things. If a prompt touches a file, there is an edge between the trace and the file. If an edit changes a file, there are edges connecting the trace, the edit, and the file. If a command fails, the command can connect to an error. If a memory is created from a group of events, the memory connects back to the source trace, files, edits, and errors. That is important because the memory is grounded. It knows where it came from. A normal note might say, auth validation belongs in middleware, but a graph memory can connect that lesson to the actual files, failed tests, errors, and edits that produced it. That gives recall more to work with than plain text. It also means the system can begin to notice patterns that are not obvious from words alone. RadialRecall. This is where the name comes from. When a new task starts, RadialRecall creates a new trace node. When it looks outward through the graph, at radius 0, it has the current trace. At radius 1, it has directly connected files, commands, errors, and recent traces. At radius 2, it may see related edits, memories, and previous work. At radius 3, it sees a wider project neighborhood. So, it builds a kind of radial profile around the current task. Then, it compares that neighborhood to the neighborhoods around existing memories. If the current task graph neighborhood looks like the neighborhood around a prior memory, that memory can wake up. So instead of only asking, does this prompt share words with this memory, RadialRecall asks, have we been in this kind of project situation before? That matters because two coding problems can look different on the surface, but share the same structure. One day you might say, water seams between chunks. Another day, transparent blocks split at chunk boundaries. The text is different, but the graph may point to the same region. Chunk.cs, world.cs, transparent rendering, chunk boundaries, neighbor lookup, previous boundary fixes. That is the RadialRecall idea. Recall by graph neighborhood, not just text similarity. Feedback, what makes it dynamic. The most important part of RadialRecall version 0.02 is the feedback loop. When memory context shows memories, RadialRecall creates a packet. That packet records which memories were shown for which task and with what scores. Then the agent can call memory feedback. A memory can be marked as applied, dismissed, uncertain. If a memory was applied, its utility goes up. If it was dismissed, its noise goes up. If it is uncertain, the system records that without making a strong update. This is what makes the system more dynamic than a simple lookup. A normal retrieval system says, here are relevant chunks. RadialRecall tries to ask, did this memory actually help? Should it wake up more easily next time? Or was it noise? A memory that helps can become stronger. A memory that distracts can become weaker. And if a memory becomes too noisy, it can go to sleep or become archived. That part is important. A good memory system should not just remember, it should also know when to stay quiet. Because bad memory is worse than no memory. If the agent keeps seeing irrelevant context, the memory system becomes a distraction. So RadialRecall is trying to make memory selective. Alright, let's go into the toolset. The current toolset is pretty small. We have a tool called memory context, which is the main recall tool. It is called near the beginning of a task. It creates a trace node, connects known files and recent work, scores memories, returns the most relevant ones, and records a packet. Another tool is memory feedback. This tool records whether the memories were applied, dismissed, or uncertain. Another is memory recap. Looks at recent graph activity and decides whether a new memory should be created or whether an existing memory should be reinforced. Memory status is the dashboard. It shows the state of the memory graph, nodes, edges, memories, packets, ledger events, recap pressure, and overall health. And memory audit. This helps inspect the system for duplicate memories, noisy memories, open packets, or other issues. There is also an OpenCode plugin that records activity while the agent works. File reads, edits, patches, commands, command failures, and session idle events. The plugin matters because we do not want the agent to manually write notes every time something happens. The memory system should observe signals from the actual work. Low token design. This part is really important. RadialRecall is not supposed to rely on heavy LLM use for every memory decision. If every prompt creates another sub-agent call, and every tool event creates another summary, and every memory decision requires the model to reread the session, the system becomes too expensive and too slow. At that point, memory becomes a token tax. So RadialRecall is designed to do most of the work locally. Writing JSON files is cheap. Creating graph nodes is cheap. Creating edges is cheap. Scoring memories is cheap. Updating utility and noise is cheap. Changing a memory from active to sleeping is cheap. The model should only receive the useful results. Ideally, that means 1 to 3 compact memory briefs. Not the whole graph, not the whole session, not a giant pile of notes. The memory system should act like a signal layer around the agent. It watches the work, computes locally, and only sends back memory when it is likely to matter. That is what makes the approach feasible long term. How this helps OpenCode. RadialRecall does not make the underlying model significantly smarter, whichever model you guys are using. What it gives OpenCode is project continuity. It gives the agents a way to remember. This repo uses PNP. This test command worked before. This auth issue was caused by middleware. This chunk boundary bug involved neighbor lookup. This previous memory was dismissed and should stay quiet. The agent still does the coding. RadialRecall supplies the memory signal, and that distinction matters. The goal is not to stuff more context into the model. The goal is to recall better context, the right memory at the right time, with enough structure to be useful. Limitations. So, this is very early phases, and this project, this repo, is still experimental. There are real limitations. Starting with, the benchmark is still synthetic, so it does not prove this improves every coding task. The scoring is still heuristic. The recap system can create useful memories, but the memory format is still simple. It's not as complex as something that I would like. The graph is currently JSON backed, which is good for transparency, but eventually it may need compaction or indexing, and memory can become noisy. That is honestly probably the biggest risk. If the system stores too much or recalls too aggressively, it becomes worse than useless. It starts wasting context and distracting the agent. That is why feedback, suppression, and auditing are core parts of the project. So, just a recap. RadialRecall is a repo-local graph memory layer for OpenCode. It records project activity as nodes and edges. It recalls memories by graph structure. It tracks which memories are shown. It learns from applied and dismissed feedback. And it tries to do all of that without becoming a major token burden. Hey, nice! You made it to the end. Very few people make it to the end of these long-form videos, so good on you, and thank you for watching. If you liked the ideas talked about in this video, please consider hopping over to GitHub and giving the RadialRecall repository a star. As you know, these videos take time and effort to make, and as you probably have noticed, my channel is not very large. My last video got like 50 views, so if you want to be one of the early supporters of my channel and this kind of content, subscribing, liking, and especially leaving a comment really helps. It helps the channel, but it also makes it feel like the work I put into these videos are not just going to waste. Again, thank you for watching, goodbye, and peace.